Good day everyone, I am Decadet Batucan Victor Joseph, and for today's video I will be demonstrating you how to calculate a celestial body's azimuth using the ABC table. Okay guys, so to calculate a celestial body's azimuth using the ABC table, so we first thing to do is to calculate its GMT, the LHA, the GHA, and the declination. And so for today's video, we have three problems. So for now, number one, we have a position 10 degrees north, 19.0 minutes for the latitude, and for the longitude, we have 123 degrees east, 53.0 minutes, having the date January 11, 2017. So we have a local time of 16 hours, 18 minutes, and 25 seconds. And a zone description of +8. So we will calculate the sun's GHA, LHA, and declination. So first, we need to subtract the local time to the zone description. So we have here 08 hours, 18 minutes, and 25 seconds. So next step is to calculate the GHA of the sun. To solve, we will use the nautical almanac. So after locating it, we will write down the day, the zone description, the minutes and seconds. So next is we will open the page between the dates of January 10 to January 12 in the almanac. So it is due to the scenario description. So next is to identify the column of the sun on the 11th day. Then take note the values found. So for the GHA from the 8th hour, we have 298 degrees 00.7 minutes. So next is to repeat the process to get the minutes and seconds. So in the almanac, we will just locate, so it gives us the value of 004 degrees 36.3 minutes. So we will just add both the GHA to get the final GHA, which is 302 degrees 37.0 minutes. So next is for the declination of the sun. So to solve it, we will still use the nautical almanac between January 10 and January 12. So next is you need to look down the column to get the value. So 8 hours due to the zone description. So that gives us the value 21 degrees south, 45.1 minutes. So next is to find the value of the change of declination. So it gives us the value of 0.1. So we will just add. So we will have 21 degrees south, 45.2 minutes. So next is the LHA. So all we need to do is subtract the GHA and the longitude. So we have LHA is equal to GHA plus easterly longitude. So we will have now 302 degrees 37.0 minutes plus 123 degrees 53.0 minutes. So we will just subtract because it is in different direction. So we have the LHA of 66 degrees 30 minutes. So for number 2, so for the second problem, we have provided with the position of 10 degrees north, 19.0 minutes for the latitude, and the longitude of 123 degrees east, 53.0 minutes. So it is in December 1, 2017, and have a local time of 05 hours, 20 minutes, 21 seconds, and a zone description of +8. So to calculate the planet Jupiter, GHA, LHA, and the declination, so first is to calculate the GMT by subtracting the local time. So we will have 21 hours, 30 minutes, 21 seconds. So for the GHA, we will still use the nautical almanac and locate the values. So we have 165 degrees, 58.5 minutes. Next is 005 degrees, 05.3 minutes. So it is just found in the almanac. So we will just add the GHA to get the final GHA. So we'll have 171 degrees 3.8 minutes. So next is for the declination. To get the value, we will still use the nautical almanac to get the value in between November 30 and December 2. So we have a value of 14 degrees south, 10.3 minutes. So next is for the value of the change of declination. So still it can be found in the almanac. So we'll have 0.2, thus it provide 0.7. So we will add to get 14 degrees south, 11 minutes. So for the LHA, we will still use the formula GHA plus easterly longitude. So we have 171 degrees, 3.8 minutes plus 123 degrees, 53.0 minutes. So we will have the LHA of 294 degrees, 56.8 minutes. So lastly is for the third scenario. For here in our third problem, we have given a value of 10 degrees north, 19.0 minutes, and 123 degrees 53 minutes. So this is for the longitude. So we have it is in a day of December 5, 2017. So local time 03 hours 32 minutes 57 seconds and a zone description of +8. So we need to calculate the star Mirkaf, GHA, LHA, and declination. So again, first step is to subtract the local time of the zone description. So we will have 19 hours 32 minutes 57 seconds. So next step is for the GHA of star Mirkaf. We will use the nautical almanac. So we will just select pages from December 5 to December 3 to December 5. So for the value of the GHA from the 8th hour, we have 358 degrees 46.7 minutes and 008 degrees 15.6 minutes for the second one. So we will just add. So we have the final GHA of 007 degrees 2.3 minutes. And next is for the SHA, or the sidereal angle of the star. So we will just locate the value in the nautical almanac under a specific star. So we have 308 degrees 35.5 minutes. So we will just add the GHA and the SHA to get the GHA of the star, which is 316 degrees 37.8 minutes. So next is the declination. So for the declination, it is still found in the nautical almanac. So the value of the declination is 49 degrees north 55.4 minutes. So lastly, for the LHA, we will use the formula GHA plus easterly longitude. So we have 315 degrees 37.8 minutes plus 123 degrees 53.0 minutes. So we will just add to get the final LHA value of 79 degrees 30.8 minutes. So after solving all of this, we will just fill in all the values that are acquired from the problem. So also input the ABC values using the ABC tables. So in order to fill the ABC table, just find where the latitude and the LHA intersect and fill the values in the table. So for number 1, we have an azimuth of 62.8 degrees southwesterly and a true bearing of 243 degrees. So for number 2, we have an azimuth of 70.4 degrees south easterly and a true bearing of 109.6 degrees. And lastly, for number 3, we have an azimuth of 39.2 degrees northwesterly and a true bearing of 320.8 degrees. So now that we have calculated the celestial body's azimuth using the LHA table. So that is all, guys. Thank you for watching.